Good morning. What up, my people? All right. So today we're going to look at line of best fit and correlation. I know Friday's notes are pretty long, so I'm going to try and keep this one a little bit shorter. It's just a review of that content from Friday. We're going to use Desmos again and just get into some of those things that we talked about, obviously, on that day. So let's go ahead and get started. In the top here, line of best fit, 4-4 correlation, quick vocabulary review. There are a couple different ways that you can describe a scatter plot. The first way is talking about the type of correlation. All right, so that can be either a positive, a negative, or if there's no real correlation, that's what you'll put there, is just no correlation. Okay, so these first three examples, you can see this line or these dots seem to go in a positive direction. So we would call this a positive correlation. Okay, this trend line seems to go down from left to right, so we would call that a negative correlation. Okay, and the last one, notice that they're just kind of scattered around. Like you could draw a line anywhere through and it wouldn't really show any more or less to be in line with the dots. So these are ones that we could say that there are no correlation. Okay, so this is like saying that the rain outside does not affect your grade in class, right? There's no real true correlation with that. Okay, the other way that you can talk about it is whether it's a strong or weak, right? So we would describe it in two ways. We would say, and also there is a new one too, there is a moderate, okay? So strong is typically an R value, either like, the absolute value of R, so it would be either greater than or equal to like a 0.7 to 1.0. A weak correlation would be somewhere between that. So we would say like 3 to 0.3 to 0.7, and then moderate. Or that would be the moderate. And then weak. Actually, I'd probably even say that this is probably going to be a 0.4 for moderate. And then for weak, it'd be like 0.1 to 0.4. Okay, so somewhere around those. Yeah, so somewhere between those numbers. All right, so if you look at a graph, though, it's a little bit easier because you can really tell, like, these dots are all really close together, so we're going to call that a strong correlation. And that would have an estimated R value somewhere around, this one's pretty close, so I would say like a 0.9, 0.8, 0.9, something like that. Okay, this one's still a positive correlation, but it's probably more weak because they're pretty spaced out. Okay, that one might even be a moderate. We would have to check that one. So that would be somewhere, I would say, around like a 0.3 or a 0.4 in terms of its correlation. Okay, now for the 5 graphs above, approximate the R value correlation coefficient of each. Today we'll be able to accurately calculate this. So I'm just reading right there. So we just did that. Approximate, well, this one, it looks really close here. So I would say probably this one again is probably a 0.8, but it's negative, so it's a negative correlation, so this would be a negative 0.8. Okay, this one is positive on the left here, and I would say probably about the same, if not a little bit less, so this is probably a 0.7. And this has no correlation, so this is R equals 0, okay, because it's so spaced out. And again, we already kind of estimated those. Okay. So, moving on, we're going to go through some examples and we're going to use Desmos. So, Mr. Step is looking to move into the city and found a few apartments on Zillow that are for rent in Columbus. They are listed below. So, this is the amount that each costs per month. Okay, so this is monthly rent up here. Holy cow, that is an expensive apartment. Oh, by the way, these are accurate. I think it was Mr. Helmlinger that looked these up for us, and these are accurate prices of apartments around Columbus. So if you're wanting to live on your own, I hope you have $1,800 to spend a month per month on rent. And then down below, this is how much area it is, so how big the apartment is. So obviously the most expensive should have the most area. All right, so we're going to type these into Desmos, but there's a little shortcut if you click this link. Let's see if I can do it. Open in Safari. Okay, cool. Yep, just continue and log in. See if we can get it to work here. All right. I'd really like you to open if you would. There we go. So you might have to log in and do it again, but all right. So we are going to copy and highlight these cells. Let's see. Go all the way down here. Copy. Okay, now let's go into Desmos. Okay, in the top left, you're going to hit that plus sign, and then table. Okay, and then you're going to paste them in somehow. I don't think it's going to let us. It let me before. Let's try this again. Copy. Oh, it's not working. Okay, well, let's just do this. Let's go into this one, and we'll pull up Desmos right beside it. Or I'm sorry, Notability. It's going to take me a minute to fill all these in. I apologize. If I had known, I would have done it ahead of time. 1425, 1080, 1895, 1178, 1645, 1200, 816, 205. Oh, 810, 816. Okay. 3420, 2051, 1695, 1502, 1800, 1596, 1250. Yes, you will be asked to do this on the test, by the way. So I would recommend pausing the video, trying this for yourself so that you have some idea of how to do it on the test, because you will not have the PDF that says, here's how to do it. So hopefully you'll get enough practice today between the notes and the exit ticket just to be able to remember how to do this. But it's pretty simple. Okay, so now from this point, I have the entire table put in. I'm going to click down here, and I'm going to put in an expression. Okay, now, when you do this, notice at the top of this table it says x1 and y1. So just like before, we're going to type in y equals mx plus b. X plus b. Only now we're going to use y1 and x1 because that's the let's go backwards. So we're gonna go back and try this again. So it should say y1 equals m, and then x1. Oh, it's not equals. I'm sorry. It's about is what we're going to use. So this little symbol here, I was wondering why it keeps canceling it out. I hope this works. X1, there we go, plus b. So it shouldn't get rid of your data. Okay. So now there's our formula. That's y equals mx plus b, which we know that's slope-intercept. So what that does is it puts the graph right here, and it draws a line. So notice I just hit the minus, I zoomed out. Okay, so it draws a line for us, so we don't actually have to do anything. So there's our line of best fit, and that is the most accurate line of best fit according to Desmos. So calculator actually does it for us. We don't actually have to figure it out. And trust me, if you had to do this by hand, the line of best fit, it is not fun because you're working with a lot of decimals. All right, so in this information to the bottom left, okay, over here, you can see it says statistics, and it gives you an R value. That R value is our correlation coefficient. So you can see the correlation coefficient, this one is a 0.8793. Okay, what that means is that it has almost a 0.9 correlation coefficient. So it means that the cost and the square footage of the apartment is strongly correlated. They are strongly related, okay? So what you want to do is take a picture of this, copy it, and paste it into the notes, okay? So just take a screenshot of this Desmos page when you make it full screen, and then copy and paste it right here. I'll let you do that, okay? Right here, sorry. All right, so that gives you an idea. Now, what is the equation for this? Well, we wrote it down, y equals mx plus b, but what they want to know is what is the actual equation? Well, if you look at the bottom, so right over here, okay, you have an m and a b. That's your slope and your y-intercept. So this is y equals 0.444x plus the y-intercept is 546.5. Okay, so that if you were to look on our graph, 546, yep, you can see it's going to go right through there, 546.525, or 546.527. Okay, so that's our equation in line of best fit. Now the correlation coefficient, as I mentioned, R equals 0.8793, so that means it's very, very strongly related. All right, so that's how you do that. Now, this is all the information to do that, okay? And then describe the correlation shown in this scatter plot. We would say that it is a very strong positive, this is number 3, correlation. Remember, 0.8 is definitely strong. Use your line of best fit to predict the size of apartment he could afford if he wanted to spend $850 on rent. Okay, so remember that rent was our x value, right? So using that equation was y equals mx plus b, where m is 0.444, times 850, because that would be his rent, plus 546.527, or 53. Will give you, if we round it to a whole number, $924. That's how much Mr. Stepp could expect to pay, or that's how much square footage you could expect it to have. So 924 square footage. Okay. If Mr. Stepp wanted an apartment that had 2,000 square feet, how much you'd expect to spend each month? So this time we're going to put the 2,000 for the y. Okay, 0.53. Okay, we're going to plug that in and solve for x. So subtract 546.53, subtract 546.53. Okay, and that would give you, well, let's just use our calculator. 2,000 minus 546.53. And then divide that number by 0.44. He could expect to spend $3,274 a month. $3,274. Okay, so $3,074 per month. That's a lot. But 2,000 square footage, that's a pretty big apartment too. All right. So let's do one more like that. Insert the picture. We don't really need to do that. But we're going to do, I'm going to do Desmos off to the side here. Okay, we're going to do it with the meal tips. So how much to leave a tip for. Okay, so let's go ahead and cross this one out, cross that one out, cross that one out. You can leave the formula, and let's just fill in different numbers here. And if you go to the X column and delete those, it'll go pretty quickly. All right, so $4.75 is the meal cost, and 0.50 is that first tip. 6.84, 0.90, 12.52, 1.5, 20.42, $3. Some of these people I feel like are tipping very cheaply. $8.97, they leave a $1 tip. Kind of cheapos. All right. So line of best fit. Okay. Given that information, the line of best fit, y equals, our m here is 0.16, we'll say. Okay. And our slope, or y-intercept, is negative 0.3. Okay, so there's your line of best fit. It says if the diner, also what is the R value here? Let's type this in. This is 0.99. Okay, what kind of correlation? Clearly very strong, positive with 0.99. Okay, So it's 0.99 and then a strong positive correlation. There's your line of best fit, given the information that Desmos gives us. And lastly, it says if the diner orders a meal costing $10.50, how much tip should the waiter expect to receive? Show your work. All right, so the tip, according to this, we would plug it in, 0.16 times 10.50 minus 0.3. Okay, that's really all you have to do to show your work. Then just plug it into Desmos. Okay, they should expect to receive $1.38. It's not very much. I feel like the going rate should be 20%, but some people are just kind of cheap. All right, so that's how you do it. Okay, so you're going to use Desmos on your exit ticket today too. Let me know if you have any questions. Again, there's a PDF file in Canvas that you can follow along while you're putting this in, but you're just going to do the same steps to find the correlation coefficient and the line of best fit that goes through the scatter plot in the best way possible. Okay? All right, so you guys have a great day, and